Naive-Bayes classifier algorithm. As we know, supervised learning is classified into two categories. Number one, regression, and second one is classification. Naive-Bayes classifier algorithm is the type of classification. So, generally, this algorithm is based on Bayes theorem. Bayes theorem is used for solving classification problem. Generally, it is used in text classification, which includes high dimensional training dataset. It is a probabilistic classifier, which means it predicts on the basis of the probability of an object. So here, as we know that classification problems based on categories or categorical based data, so we consider probabilities. Some popular examples of naive-Bayes algorithms are spam filtration, sentimental analysis, classifying articles, etc. Why it is called naive-Bayes? There is a theory, means this is the combination of two words. So it can be described as naive. Naive means it assumes that occurrence of a certain feature is independent of the occurrence of other features. Means we consider all the feature, we find independent feature, and we find the relationship between the certain feature is independent of the other features, such as if the fruit is identified on the basis of color, shape, and taste, then red, spherical, and sweet fruit is recognized as an apple. Hence, each fruit individually contributes to identify that it is an apple without depending on each other. So, on the basis of their shapes, taste, red, size spherical, the relationship find the categorization or the occurrence of the object. Why it is called naive Bayes? So again, the second part is Bayes. It is called Bayes because it depends on the principle of Bayes theorem, and Bayes theorem suggests that probability of a hypothesis with prior knowledge, that is, it depends on the conditional probability. Here we consider posterior probability, likelihood probability, prior probability, and marginal probability. So to calculate posterior probability, like probability of A over B, can be written as probability of B over A into probability of A by probability of B. So posterior probability is nothing but that is probability of hypothesis A on the observed event B. Probability of B over A, that is likelihood probability, it can be considered as the evidence given that the probability of a hypothesis is true. Prior probability is nothing but that is probability of hypothesis before observing the evidence, and the marginal probability is the total probability of the evidence. So this formula is used and it is known as Bayes theorem. Working of Bayes naive-Bayes classifier, that is, suppose we have a data set of weather conditions and corresponding target variable play. So using this data set we need to decide that whether we should play or not on particular day according to the weather conditions. So to solve this type of problems we use naive-Bayes theorem. So first of all, convert the given data set into frequency tables. We create frequency tables, likelihood tables by finding the probabilities of given features, and then we apply Bayes theorem. So there are three steps. First of all, we convert the given data set into frequency tables, then we calculate likelihood tables, and then we apply Bayes theorem. So here we have a problem. We have to find the player should play or not in the condition if the weather is sunny. So we have some data sets, like there are some 13 data sets for the season outlook, and the condition is whether he or she should play or not. So here, by using this data set, as we see, first of all we need to create frequency tables. then likelihood tables, then we apply Bayes theorem. So here we are creating frequency tables for weather conditions. We have overcast, rainy, sunny. So here overcast, rainy, sunny, and we find the conditions of yes and for no. In the previous table we calculate all the overcast for yes or playing no. In the same manner all the yes for rainy and all the no for rainy, and in the same manner all the yes for sunny and all the no for sunny. So here we are calculating the total is 10 for yes and 4 for no. Now the second step is to create likelihood table for weather conditions. So again we are considering likelihood table, and in the last column we are calculating the probabilities. So here 5 over 14, as we have total number of conditions are 14 here from 0 to 13, that is total 14 sets. So here overcast, probability, rainy, sunny. So now we apply Bayes theorem. We have to calculate probability for yes in the sunny season. So the formula can be considered as probability of A over B, that is posterior probability, equal probability of V over A into probability of A by probability of B. Here we apply, so probability of sunny over yes into probability of yes by probability of sunny. We have already calculated the values, we put the values, and here we get 0.60. In the same manner we are calculating for the other instance, that is for no. So probability of no over sunny equal probability of sunny over no into probability of no over probability of sunny, and here we are, after putting the values, we are getting 0.41. So here we can see that probability of yes over sunny is greater than probability of no over sunny. So now it can be seen that player can play the game on a sunny day. So this is the way to solve naive-Bayes type problems. Here are some advantages and disadvantages of naive-Bayes classifier. Naive-Bayes is one of the fast and easy machine learning algorithms to predict a class of data sets. It can be used for binary as well as multi-class classification. It performs well in multi-class predictions as compared to the other algorithms. It is most popular choice for text classification problems. Here some disadvantages of naive-Bayes classifier, that all features are independent or unrelated, so it cannot learn the relationship between features. So there are the types of naive-Bayes model. We have three types of naive-Bayes model which can be classified as Gaussian, multinomial and Bernoulli. In case of Gaussian model follow a normal distribution, means predictors take continuous values instead of discrete. Then the model assumes that these values are sampled from the Gaussian distribution. In case of multinomial classifier is used when the data is multinomial distributed. It is primarily used for document classification problems. It means a particular document belongs to which category, such as sports, politics, education, etc. In the same manner, the third type of classification is Bernoulli. In this type of classification, the multinomial classifier same as multinomial classifier, but the predictor variables are the independent booleans variables, such as if a particular word is present or not in a document. This model is also famous for document classification tasks. So that was naive-Bayes classifier. Thank you.